So what we're going to do today is we're going to look more closely at marginal means and how they're calculated. We're going to look at cell means, how they are calculated. We're going to look more closely at the 3F ratios or F values that are going to be computed in a two-way ANOVA. Because you're going to have one F value for hemispheric dominance, one for marijuana, and one for the interaction. So every two-way ANOVA will end up generating 3 F values. We're going to look at that. And then we're going to look up or look at interactions, interaction effects in more detail. And I want you to really get a good grasp of what an interaction effect looks like. If we have time, and we'll see, we're going to start talking about tests of simple main effects, which we were introduced to in the lab very briefly, but we're going to go into them in more detail in this lecture or maybe the next one. All right, so let's look at a little bit of trivia before we move any further into two-way ANOVAs. Now, please note that even though we call this trivia, it is not trivial. So you do need to know and understand what I'm about to show you. Sometimes when you're reading an article or a chapter, you may see something that looks like this. You may see that they ran a 2x3 ANOVA, or maybe they ran a 4x2 ANOVA. Now, first of all we know is that it was an ANOVA. We don't know if it was an independent ANOVA or a repeated ANOVA. We don't really call them dependent ANOVAs, although that would make sense. But when we refer to ANOVAs, we refer to them as either an independent ANOVA, a repeated ANOVA, and as long as you have at least 2 or more factors, you can have a mixed ANOVA. All right, and so we really don't know what kind of an ANOVA they ran just by seeing the word ANOVA. But this 2x3 does tell us something, and same thing with 4x2. If we look first here at a 2x3 ANOVA, what we know just by, quick visual inspection is that it's a two-way. We also know that this first factor had 2 levels. This next factor had 3 levels. So again, we know it's a two-way. Why? Because there's 2 positions here. All right, so we have one factor represented by the first position and the second factor represented by the second position. All right, and then the actual number tells us the number of levels that factor has. So factor 1 has 2 levels, and factor 2 has 3 levels. So in the case of our hemispheric dominance and marijuana example, we would probably want to phrase it this way if we identify factor 1 as hemispheric dominance. If we say factor 1 is hemispheric dominance, then it's a 2x3, right? Because we had 2 levels of hemispheric dominance, 3 of marijuana. What would we have to do if we called this a 3x2? Well, if it's a 3x2, then our first factor, again, remember, pretend this is a 3, our first factor is going to have to be hemispheric dominance. And then if this is a 2, that means the second factor would be, I'm sorry, did I get that mixed up? If this is a 3, that would have to be marijuana, right? First factor would have to be marijuana because there's 3 levels. And if this is a 2, this would have to be hemispheric dominance because there are 2 levels of hemispheric dominance. All right? Okay. I don't actually know if I messed it up, but now I'm questioning myself. Normally, I just look at your faces and somebody raises their hand and said, I think you mean, but with nobody here to tell me, I have to be sure that I got it right. Okay, so let's just stick with this and let's just say there are, our first factor is hemispheric dominance and there's 2 levels, and marijuana is our second factor and it has 3. All right, what about over here? Well, I didn't give you an example of a 4 by 2, but hopefully by now you know what this means. So you should be able to tell me how many factors are tested. And of course, there's 2, all right, because we have one position here for the first factor and one position here for the second factor. Our first factor has 4 levels. And how many levels does our second factor have? 2 levels, all right? We have said 2 by 4 instead of 4 by 2? Yes. But then we're going to have to redefine which factor we call factor 1 and which factor we call factor 2. So whatever you decide to call factor 1, make sure that is the factor that has 4 levels. And whatever you decide as factor 2, that has 2 levels. Okay? So what if we had a 4 by 2 by 3? How many factors would that have? 4 by 2 by 3. It has 3 factors, right? Because if I add another, by 3 here, like 4 by 2 by 3, then I've got 3 positions, so it's 3 factors. And how many levels would the third factor have? Well, if it's a 4 by 2 by 3, it means that the 3 here is telling us that there are 3 levels of that third factor. Right. How many marginal means would this type of ANOVA have? Right? Well, think about it. If you have 2 levels of factor 1, you have 2 marginal means. If you have 3 levels of factor 2, you have 3 marginal means. So putting it all together, all you have to do is add. All right? There's 2 marginal means here plus 3 marginal means here. That gives you 5 marginal means. Now, how many cell means would you have? Well, instead of adding 2 plus 3, this time all you need to do is multiply the number of levels together, and that will tell you the number of cell means. So 2 times 3 is 6. Now, visual helps. So let's look. Whoa, I guess the visual is coming up. Let's do this one, and then I'll show you the visual. So again, how many marginal means? There's 4 levels of factor 1. That means 4 marginal means here. 2 levels of factor 2. So that means 2 marginal means here. Add them together and you get 6 marginal means total. How do we find the number of cell means? Don't add them this time. This time you're going to multiply them together, and that will tell you how many treatment combinations or cell means, and here we can see that there's 8. Now it's time for the visuals. All right, so over here, remember we have a 2 by 3. We can either represent it this way or this way, right? This way, 2 columns by 3 rows. Over here, 3 rows by 2 columns. It doesn't matter which layout you choose. It is the exact same ANOVA. All right, now, if we wanted to know how many marginal means, let's look at this one. Well, you have 2 columns, so you're going to have 2 marginal means, 1 for each column. And you have 1, 2, 3 rows, so you're going to have 1, 2, 3 marginal means over here. So to get the total, you just do 3 plus 2. How many cell means? Well, these are your cells, right? So we have 6 cells, so we'll have 6 cell means. So in this case, could we have found that? You just multiply 2 columns times 3 rows gives you 6 cells. All right. Over here, same idea. This time we'll look at this diagram. Again, these are the exact same ANOVA. You can represent them as either 2 columns and 4 rows, or you can have 1, 2, 3, 4 columns and 2 rows. Same thing. Okay, so how many marginal means? Well, you're going to have a mean for each column. So you're going to have 1 marginal mean, 2, 3, and 4. Whoops, no, go back. Sorry about that. Sometimes if I tap, right, it advances. So we established that we have 4 columns, so we're going to have 4 marginal means, and we have 2 rows, so we're going to have a marginal mean here and a marginal mean there. So if we've got 4 plus 2, that gives us 6 marginal means. How many cell means? Well, remember, cells are the treatment combinations, and we have 8. How do we find that? Like as a shortcut? Just multiply. All right, so if you have 4 columns times 2 rows, that will give you 8 cells. Okay? All right, so again, ANOVA trivia that is not trivial.